Charlie mentioned all the people's names, but I think I missed some team members. But I want to emphasize we have a very large team. I lead the team, and Dr. Seth is a co-PI, Dr. Gary Adawade is a co-PI. We are co-PIs, but other people play the same role. We just put the 3 people as co-PIs just for simple reason, is to simplify the paperwork. It's involve a lot of paperwork. So if everybody co-PIs, the signature process take a long time. But those people with these collaborators they're playing more important roles. So if I miss your name, let me know. Sorry, but they're all doing great work. But we all know that aflatoxin is a major issue for corn, and the aflatoxin contamination causes a lot of economic loss for producers and safety issues. So we all know this slide, so I'm not going to spend too much time on that. And aflatoxin is a major issue for Texas. So as breeders, we are dealing with this major issue. It's a complex, and some breeders, if I go Midwest, people say good luck, develop aflatoxin resistant corn. In other words, the translation is that some breeders believe it is almost impossible to develop aflatoxin resistant. Our team believe we can make some difference. So we heard a lot of approaches to mitigate the aflatoxin problem. One approach, of course, is through the management practices, through plan early, harvest timely, and these kind of issues, and avoid plan going through the drought stress. The other, we just heard, applying a non-toxic strain, and we believe we can contribute some by developing and deploying aflatoxin-resistant hybrids. And we further believe that aflatoxin-resistant and drought stress tolerant corn is just one of the approaches. And we believe that our team believes that we can use the craft management system and apply a toxic strain to this new generation hybrids. We can reduce aflatoxin contamination tremendously. And that's one of the approach we're going to talk a little bit later on, is when we have a big project, we're going to test that hypothesis. To develop the corn for low aflatoxin, there are basically 2 approaches. One is use a transgenic approach that runs later. Sarah is going to talk about and one approach. And our team, we are using the native resistant genes and try to improve the adaptation to the south environment. And we believe one of the major problems is our hybrids are not well developed to the south environment. Most corn hybrids develop in the Midwest, which is marking south. So they're not used for high temperatures and frequent drought stress. So the specific objective for this project is one is to build new high yielding lines for making hybrids that can yield well and also low aflatoxin in the south environment. One key major difference is our team emphasizes yield. In the past, we emphasized aflatoxin resistance. Now we must emphasize yield. Without yield, our new lines will not get much attention. And second, and we want to do extensive testing. So we have a very large collaborative project. This team involved almost all the breeders, geneticists, working on corn and aflatoxin in the southern states. So how do we do this? And we need to avoid these things. We want this kind of corn. Okay. So again, the major goal is high yielding, low aflatoxin, multiple stress tolerant hybrids. Each team member take a different approach. In my program, and some other people, we use trying to improve drought and heat tolerance. The Mississippi group, Dr. Pavilion emphasized kernel resistance and association mapping approach. We're all selecting for a tight husk. This is a good trait for south environment, But if you move to the place north at Highway 40, people will throw away these hybrids because these hybrids cannot dry, when they in the season cannot dry down, so it's a bad trait. But we need tight husk to avoid insect damage, especially corn earworm, fallingworm problems. And we try to improve corn earworm and fallingworm resistance. We do cordial testing, and we also trying to find a new source of resistance. And each team member emphasize this approach differently, but we're looking at things comprehensively. One of the comprehensive tests is the Southeast Regional Aflatoxin Trials or test, as we call SERAT. This was initiated in 2004 and it continued to expand. It's one of our major components program. Have almost all the members in this project are the core players of this test. And we do uniform tests in Texas, Mississippi, Georgia, and North Carolina. We have an industry involved, Monsanto Pioneer, and BH do in-kind support. We grow the hybrids, lines in different environment. We inoculate the field either by spraying the colonized kernels in the field. Take example, this slide from Dr. Seth Murray. Some people may do different method by inoculating conidia to the cell channel. And they harvest grains and analyze aflatoxin with VIACM or other methods. Now, I want to spend a little bit more time and report where are we now, what kind of progress we made, and I think that's what you want to know. We use your money. What do we do? One thing that we're proud to say that we have some line released, and now one of my lines are in commercial hybrids, directly used as a parent line produced hybrids. The hybrids in commercial in 2012, and the hybrid continued to gain market share. And this hybrid has low aflatoxin and high yield. Now the top, this is the hybrid yield, and these are 3 commercial hybrids. You can see the yield is not bad compared to the commercials. But if you look at the aflatoxin now, these aflatoxins are inoculated field. Even under inoculated condition, this hybrid has significantly lower aflatoxin. So if you believe that if the atoxic strain can work, if we put an atoxic strain onto this hybrid, we may significantly reduce the aflatoxin. And this hybrid on the market has excellent yield, excellent grain quality, and low aflatoxin. And there are second cycled hybrids coming to the market, so it's exciting. Okay. And my program also, we're looking for new source of genes from wild species, teosinte, and this is the ear from corn cross with teosinte F1 hybrid. And the teosinte ear is different, it's just a weed. And after back cross, we made this one to this. And from these breeding crosses, we select new lines. And these lines, if you look at the aflatoxin level, some of the line test crossing, I'm not good at controlling stuff. Math is not ready anymore. Anyway, I'm going to use this so you can see some of these test crosses, the West Lyco and Mississippi, the low aflatoxin compared to these commercial checks. But if you look at the yield-wise, they yield very well compared to commercial. So there are new source lines in the pipeline. We should release this in the next couple of years. Last year we released 5 brown middle lines, TS206 to TS210. These lines were selected especially for silage But we also test for grain. It was surprising. These lines do very well in southern states. They don't yield well. Grain yield fairly low in Texas high plains. But when we go to south, these hybrids also produce excellent grain yield. So we are testing for aflatoxin this year, see if these hybrids have a low aflatoxin. Okay. So if they do, then we got hybrids already. And Dr. Xinzhini, USDAARS, he has 2 lines ready to release for FAW. It's a 4 armyworm resistance, 1382 and 1430. This line resistant to aflatoxin and low in, resistant to 4 armyworm and low in aflatoxin, line per se, and also in hybrids. And Dr. Brian Scully has several lines. Dr. Baudru Guer also have several lines here, but I did not get the slides, so I'm reluctant to post the results in the slide without the permission, so I did not have slides for. I just want to mention Dr. Baudru Guer and Brian Scully. They also have several lines ready to release for low aflatoxin. Okay. Dr. Seth Murray released several lines last couple of years. And he has several new lines in the pipeline, and he also made a 2 new synthetic populations for selecting new lines. This is TX736, TX739, TX740. These 3 lines low in aflatoxin. He sent me these slides last night, 12:30. I was working on slide. And it's very crowded, but the bottom line is he has quite a few lines from Lamar population. They have excellent yield, low aflatoxin, so they should come to the market in the next couple of years. He made 2 new synthetic populations by intermating 4 lines, TS772, MP313E, TS740, MP715. These the 2 lines from Dr. Paul Williams' group in Mississippi. TS772 and TS740 is from Dr. Seth Murray's group in College Station. He made a 4-way cross, intermated twice, and this year we're testing in SERAT and also multiple location selection. He also selected 14 made 14 8-way crosses from using the resistant lines identified by Mary Robert in associate mapping. These will become a new breeding population. Dr. Paul Williams' group, and here is over there Paul hiding there pollinating the Maryland, taking notes. They are looking for genes and gene expression in addition to breeding. They're especially looking at the gene functions and trying to understand the genetic mechanism. Maryland also leading a large project on association mapping. Most people in this project involved in this association mapping, we found some genes associated with aflatoxin resistance, and also working with Dr. Matt Kowalski, identified new promising source of resistance from GEM project. GEM and its abbreviation of a germplasm enhancement of maize. This is one of the largest, actually it is the largest collaborative project in the corn breeding involving USDA, public universities, and almost all the private seed companies working together to enhance germplasm. So this is an excellent source for public breeders as they have identified some new sources. I'm going to get it too fast. Anyway, so this year with AMCOE funding, we got a $1 million USDA AFRI grant. The project title is Reducing Pre-Harvest Losses from Aflatoxin in Maize Production. through integrated breeding and pest management strategies. Dr. Seth is the project director. Tom Assay, me, Michael Brewer, Marilyn Warburton, and Dr. Paul Williams are co-PIs. Dr. Gary Adwadi, David Gibson, representing test co-producers, Matt Karosky, Dr. Xinzhi Ni, and Dr. Brian Scully are collaborators. We just get approval, we haven't get the money yet. It's not really public information. But one thing I want to emphasize is without AMCOE funding, this $1 million project is not going to be possible. We wouldn't get the funding. So with the money, we put a team together, we did some work, and this money continue serving as a seed money to help us to move forward for some bigger project and bring all the people together. So again, I want to thank the National Growers Association and AMCOE, Test Co-Producer Board, USDA and other agencies for our funding of the project. And lastly, the slides I want to show that if you see our breeding project proposal, every year they look like, format look like, and the approaches almost the same year over year. There are two things I want to emphasize. Our breeding strategies remain fairly stable. Year over year, we're also testing similar environment year over year. But one thing is changing dramatically year over year is what seeds we plant into the field. Every single season, we generate new seeds, new lines, new hybrids. We introduce new source of germplasm, make up new breeding crosses, and make new lines, make new hybrids. We test them, and we drop a lot of lines, if not promising well, and we also add a new one. So the material we're testing and growing every season is quite different. That move us forward. So I think I was too excited, I moved so fast, so I have plenty of time to answer your questions.
Wenwei, you have had some success in getting some of your material out to us.
Yes.
CNH and such. Where do we go? Is that going to get better, bigger, more lines? Do you think over time, or what's the limit?
Over time, it's getting bigger, getting better. I know Dr. Seth is working with other companies, and I'm reluctant to tell the public what hybrid is being there. But that's a confidential piece of information kind of things. Yeah, we got those lines right now. I think we license lines to all the companies, large and small companies, and some of hybrids are even moving to other countries. A couple of hybrids will be commercialized in Turkey next couple of years. Yes.
What's the relative maturity of the hybrids? The inbred that you release and the ones that you're working with?
The one released, that hybrid is 115 days hybrids, and the next generation will be earlier. We're moving to the new germplasm will be around 100 to 110. And one reason is we are selecting for short season corn lines and hybrids because of aflatoxin is one issue, and the one major issue for Texas is we are running out of water. So we got to have a short season hybrids too, so we can produce and continue grow the hybrid. I think we have some impact because a lot of companies used to be marketing the last several years. We've been making noise. Now people start testing the short season hybrid in our people, because some producers want 70-day hybrids. They want a hybrid in Canada, grow in Texas. Yes.
I've heard is synthetic four-way process using some pretty much longer than that though. So his
Yes. His maturity will be 115 to 120. Yes.
I was curious how, do you see a predominant mechanism of how resistance manifests? Do you see less colonization, or do you see fairly high levels of colonization and less toxin? Is there any generality that you see?
Honestly, we really don't know exactly what the mechanism are. If we do, we know how to develop the hardware much faster. Okay, we know what possibly involved. One, they are tolerant to high temperature. All the material we select for the tolerant for high temperature. Number two, they have at least medium resistant to corn earworm and fall armyworm. Because if we're susceptible to those two insects, ear-feeding insects, we drop those ears. So when we do pollination, we said, third is we're selecting for clean ears. That's what you tell me, less colonization. And some people believe, yeah, clean ears may have high aflatoxin. True, and I'm not arguing that. But on the other hand, if you have 10 clean ears and 10 molded ears, I'm pretty sure that 10 molded ears will have higher aflatoxin. So that's in the breeding process, we intentionally select for less colonization.